This is Victor Sheng, Associate Professor at the Department of Computer Science at Texas Tech University. I'm an active researcher in data acquisition and data preprocessing in academia and the industry. Labeling can be one of the essential steps for data preprocessing, which I'm passionate about, including single labeling, multi-labeling, and strategy for saving the labeling efforts and cost. Let's explain this concept one by one. Starting from a simple example. Imagine you got a picture of me sitting on the chair at my backyard. From a machine learning standard point of view, the picture can be understood by providing a label in the picture. For traditional single labeling, this picture can be labeled as a man. A label for one picture is a premise for single labeling. However, a single label for one picture would not match the need of many real-world applications. For example, this picture can also contain a chair and other things like flowers in the backyards. With the multi-labeling, this picture could be labeled with multiple labels, such as man, chair, backyard, and different kinds of flowers. From this simple example, you can see that multi-labeling can provide more information about a picture. In other words, you can see that multi-labeling is more powerful than single labeling. Here, I want to emphasize that multi-labeling provides more labels for a single picture simultaneously, compared to the traditional single labeling, one label for one picture. In data acquisition research, it is not necessary to manually provide all the labels for every picture in many real-world scenarios. Active learning is our research direction in machine learning to save the efforts and the cost of data acquisition. One of active learning strategies is to study how to infer labels based on already obtained labels. To briefly explain how active learning works, we can still use the previous picture example again. In multi-labeling, because labels have correlations. For example, a pair of labels such as a chair and a yard has high correlation since they often appear together. We can estimate the correlation between labels and use the estimated correlation to infer labels instead of acquiring all labels information. Active learning is essentially useful for multi-labeling. Recently, crowdsourcing platforms provide efficient, effective approaches for data acquisition. For example, AIMMO. These platforms usually provide a friendly interface for human labelers for single labeling. It is interesting to integrate AI ancestors and user interface design powered by active learning to help human labelers adapt to multi-labeling. Still go back to the picture example. This crowdsourcing platform can show human labels the correlations among labels. With the help of these correlation values, the productivity of human labels can be significantly enhanced.